can use matrices and Gauss-Jordan elimination in order to balance chemical equations. And so let's take a look at a couple examples. We've got this chemical equation here, HClO4 plus P4O10, and that's equal to H3PO4 plus Cl2O7. We need to come up with some kind of coefficients that makes this balanced here. We need to have the same number of elements over here as we have over here. So we've got A, we'll assign some values to coefficients A, B, C, and D. So we've got A something plus B something, and that's going to be equal to C something plus D something. And in the case of H, in the first compound here we have only 1. We've got none here, we've got 3 here, and none here. So 1A equals 3C. For Cl, we've got 1 here, none, none, 2. So 1A equals 2D. For O, we've got in every compound, so we've got 4 plus 10, 4A plus 10B is equal to 4C plus 7D. And then finally for P, we've got 0. For B, we've got 4. For C, we've got 1. And for D, 0. So I put those into a matrix here, but we have 4 rows and 3 columns, and that is not what we need for Gauss-Jordan elimination. So what I'm going to do, we can do this a couple of ways. We could set D equal to 0 or D equal to 1 and eliminate our most complicated equation, or we can just set a 4th column and put those all equal to 1, and it won't change the outcome. So I'll do that. And let's go ahead and do some row operations. Remember, we can change any 2 rows, we can multiply a row by a non-zero constant, and we can add or subtract from any row another row times any non-zero constant. So let's first switch R1 and R2. We'll switch R1, R2 here. We've already got the makings of the identity matrix with 1, 0, 0. We've got that second 1 in there. So let's keep with that. And then remember, what we do to the left side, we're going to do to the right side. So you've got 2, 0, 7, 0. Next, let's subtract from R2, R2 minus R1, and let's also take R3 and divide it by 10. Here's what we get, 1, 0, 0, 1, 0, 0, negative 3, 0. Then here we've got 4 tenths, 1, negative 4 tenths, tenth, and 1 tenth. On the bottom, 0, 4, negative 1, 1. 2, negative 2, 7 tenths, 7 tenths, and 0. Okay, so it's starting to come together now. Let's take and divide R2 by 3 and subtract from R3 4 tenths R1. So I divide R2 by, negative 3. Negative 3, we're going to get a 1 here. And then by taking R3 and subtracting 4 tenths R1, we're going to have 4 tenths minus 4 tenths. We'll get a 0 here, we'll get a 1 here. And again, we'll move closer to the identity matrix on the left. So we've got 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, negative 4 tenths still, and negative 3 tenths. And then on the bottom, 0, 4, negative 1, 1. So 2, now we've got 2/3, negative 1/10, and 0. Keep doing our row operations. Let's take R3 plus 4/10 R2. And so we've got a 1 here. We can eliminate this 4/10 if we just multiply this by 4/10 and add it to the negative 4/10. R3 plus 4/10 R2. And let's also do R4 plus R2. R4 plus R2 will give us 0 in this column here. Top row stays the same, second row stays the same, and we're slowly but surely getting rid of all non-zero constants so we can come up with the identity matrix. Next, we'll take R4 minus 4R3. R4 minus 4R3, that'll give us a 0 in this place here. And then after that it'll be smooth sailing. At 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, negative 3/10, and finally 0, 0, 0, and we get 22/10. Right, so 4 times 3/10 is 12/10. 1 is 10/10, so 10/10 plus 12/10 is equal to 22/10. And we get 2, 2/3, 1/6, and 0. Because this value is 0 here, it gets pretty easy from here on out. So what I'm going to do is just, we have a 0, so we're going to take, our next row operation would be to take, divide row 4 by 22/10, we're going to get 1. 0 divided by 22/10 is still 0. Right? And since we have a 0 here, none of these others are going to change as we eliminate the non-zero values in this column. Right? So we can just change these to zeros without changing anything else. So if we've got, again, 1 here, we'll take, in the next step, we'll add to R3 3/10 times R4. 3/10 times 0 is still 0, so this remains unchanged. That'll change to 0. Nothing else will change because these are all zeros. And finally, we'll get rid of this one by simply subtracting from R1 R4. 2 minus 0 is still 0, and so nothing else changes. Okay, and so what we get is A is equal to 2, B is equal to 1/6, C is equal to 2/3, and D, we have 1 equals 0. We know that's not correct, so we're going to say this is 1 and it's implied. D is 1 and that's implied. We know we can't have 0 here because we already have the compound. Right? So since we get 1D equals 0, that's a complication because we had to add the 1s. We didn't have enough spaces. We didn't have enough columns to get a proper identity matrix, and so this is what we call implied. And so we can't have 1/6 of a compound, so we're going to multiply all of these by our largest denominator, which is 6, and we end up with the final balance equation of 12HClO4 plus P, because 6 times 6, P, 4, O10, and that is equal to 2/3 times 6 is 12/3, or 4, 4H3PO4, and we're going to add to that 6 times 1 is 6, 6Cl2O7. Okay, I've got another example here, and we could do very much the same thing. I'm going to do it a little bit quicker just to save time here. So we've got our original balance equation here. We've put our coefficients A, B, C, D. We've come up with our matrix. We're going to add, again, ones. So we get a 4 by 4 matrix on the left. We can make the identity matrix with some row operations. And we'll start by dividing R2 by 2 and R3 by 3. So we're going to get our pivot positions. We're going to get ones right here, right here. We come up with 1, 0, -3, 1, 1, 0, 0, 1, 0, 1, 0, 1/3, and then 0, 1, -2, 1. Over here we've got 0, 1/2, 1/3, 0. Next we're going to take R1 and subtract from that R2, and subtract R3 from R4. R1 minus R2, that means we're going to get a 0 here. So we'll get 0, 0, -3, 1/2, -1/2, 1, 0, 0, 1/2, 1/2 here, 0, 1, 0, 1/3, and 1/3 here, and 0, 0, -2, 2/3, and finally -1/3. So now I want to just focus on which ones we want to keep. Right, we need one in each column. Right, we need only one value in each row in order to get the identity matrix. Right now it doesn't really matter what order they're in. We can switch that later. Right, and so in order to accomplish that, we're going to take R1 divided by -3 in order to get a 1 here. We're going to take R4 and multiply that by 3/2 in order to get a 1 here. 0, 0, 1, -1/6, and 1/6. 1, 0, 0, 1/2, 1/2. 0, 1, 0, 1/3, and 1/3. 0, 0, -3, 1, and -1/2. Again, we're just going to continue to eliminate these variables, right? So let's identify which ones we're keeping. We're going to do some row operations, get rid of the rest. And so I've got R4 plus 3R1. Right, R4 here, we've got a -3. We're going to add to that 3 times R1. And then we're going to take R4, multiply it by 2 after that, because if we multiply 3 by 1/6, we've got 1/2. 1 minus 1/2 is 1/2, and so I'm skipping a step here in order to save time. We're going to multiply R4 by 2 after that, and we get 0, 0, 1, -1/6, 1, 0, 0, 1/2, 0, 1, 0, 1/3, and 0, 0, 0, 1. Here we've got 1/6, 1/2, 1/3, and 0. And again, in the previous two steps combined into one, we multiplied our 1 by 3, so 3 times 1/6 is 3/6 or 1/2. 1 minus 1/2 is 1/2, and then we multiplied by 2 to get 1. 3/6 is 1/2 again here. 1/2 minus 1/2, or negative 1/2 plus 1/2 is 0, and so we get 0, and that's not going to change. And then this becomes quite easy, like previous situation. We've got a 0 here, and so we can just get rid of all of these without changing any of these here. Very convenient. And so we get A is equal to 1/2, B is equal to 1/3, C is equal to 1/6, and D, again, we've got that same situation because we added the ones in order to make it simpler for our situation. And we're going to say D is equal to 1, and that's implied. Remember, it's very important that you have a 4 by 4, or 3 by 3, or a square matrix on the left side in order to use Gauss-Jordan elimination. And if you don't, you can do it a couple different ways. I've only demonstrated one way, which is adding ones in that last column there. And either way, you'll get the same answer. Chances are you're going to come up with a 1 equals 0, so then D is equal to 1 implied, and that gives us our final equation, our final balance equation. We'll multiply by 6 here. We get 3 Fe Cl2, right? 6 times 1/2 is 3, plus 6 times 1/3 is 2 Na, and we're going to, I didn't mention this before, but we just kept PO4 as a compound. That made it easier to do our balance equation. 1/6 times 6 is 1, so we don't need to write the coefficient. Fe3, PO4, 2, and then finally D was 1 implied times 6 is 6 NaCl. And so we can use matrices now to solve chemical balance equations.